Welcome to our new video. Hello everyone. In this video we will continue to talk about the fundamental statistics functions in R. So let's get started. First we create a simple vector here to apply our basic functions. So this is just a small vector with arbitrary values. We assign this to A, and then we calculate the variance of this small sample A using the VAR function in R. As you see, that's 13.58. You can calculate the standard deviation of a sample using this SD. Standard deviation is the square root of the variance. Okay, so that's going to be square root of this number given here. As we have seen before, in R we have these data sets available. It shows us available data sets here. And we can work with this mtcars data set. And you can see this data set contains 32 observations with 11 variables. So each variable, you can see the name of the variable given by these dollar signs here. So let me close this. And we can do again basic descriptive statistics from this data set, calculate the mean for any of these columns. You can choose with the dollar sign as usual. And this is the average MPG for this data set. Again, you can do the standard deviation for this column, or you can do it for example, the horsepower, HP. Okay, so this is the standard deviation of this variable. We can calculate the association between two variables using the covariance function. It's very useful, and you can calculate the, let's say, covariance between these two variables, MPG versus the horsepower. But covariance is affected by the scale of the variables, so it will give you large numbers, and if you want to compare the covariance between different couples of variables, this will not be easy, not comparable because of the scale, but you can use the correlation coefficient to compare the association between different pairs, and correlation coefficient is always between -1 and 1. Okay, so that will be comparable between different pairs. So for example, we can calculate that for our data, two variables MPG and HP here. The correlation is negative. Negative correlation means when one of the variables increasing, the other one is decreasing. I mean, for this example data set. So there are some other examples we can construct, again using some simple vector of values. Again, you can try the covariance and then calculate the correlation coefficient like this one. They are positively correlated, and as we said, the maximum of correlation can be 1. That means perfect correlation. Whenever one is increasing by a certain percentage, the other one is also increasing in the same way. So that would be the extreme case, but you will be getting something between -1 and 1. And also we can use the plot to identify the degree of association between two variables other than the covariance or correlation coefficient. Here's one example. We can plot these two data sets, and we can see this is a very small data set, but with more observations we can see the scatter plot and identify if there is some positive or negative association correlation between these two variables. We can do another plot with the quakes data set. Remember, we have all these data sets available in R, and this one, if we look at our data, we have 1000 observations with 5 variables like earthquake magnitudes, the depth, stations latitude and longitude of these earthquakes are given. Okay, so for example, if I want to plot the magnitude and stations measuring these earthquakes, I can use this one. So this is the, so let me make it a bit smaller. So this is the identity number given for each station, and these are the magnitudes. So certain stations might have more accumulation of larger, for example, larger earthquakes. Okay. And another example, we can plot the depth and magnitude of the earthquakes this time, and we can do that. So we see this is the x-axis is the depth, and we have the magnitude for the earthquakes that are given in this data set. And again, if you are accessing the rows, like if you want to select specific rows of your data set, let's say empty cars data is given. For the first 5 rows, you can select it like this. When you don't enter anything for the column, that will take all the columns. So this is the first 5 rows in our data set, and we can see it. This is the first 5 columns. The first 5 rows. And then if you want to select, let's say, the first 3 columns, first 3 rows and 3 columns, then you can run like this. So this is the first 3 rows and columns. Okay. In R, there's also a useful function that's called table function. So that can create you some cross tabulation, and it's really nice. You can see we apply this for our the number of cylinders for our cars data set. So in the number of cylinders, basically there are three distinct values, 4, 6, and 8 cylinders for these cars, and this gives us the frequency. In our data set, we have 11 cars with 4 cylinders, we have 7 cars with 6 cylinders, and 14 cars with 8 cylinders. Okay, and this table cross tabulation function you can use, to display these frequencies and see the summary of your data easily. And we have the bar plot. This is another useful fundamental statistics plot. So let's see, in this bar plot we can see again the frequency of when we bar plot the cylinders. Okay, and we can see again the cross tabulation results here. For example, we have 11 cars with 4 cylinders, we have 7 cars with 6 cylinders, and so on. So this is also useful to display what we have seen in the table function, but we can visualize this using the bar plot. So this might be more convenient, especially if you have more number of categories, okay, for a given variable. And you can also focus your attention. I mean, you can work with some specific subsets. So you can select the subset, for example, in this AM variable. So let's go to our data here. We have this variable. So this is indicating whether our car is automated or manual transmission. Okay. So we can focus on, for example, the manual transmission cars by specifying this 0 or 1, and then we can create the cross tabulation, this frequency table, using that specific subset. So for example, if we run this will be giving us the number of cars with 4 cylinders, but they are all within AM equals to 0 subset. Okay, so we take these values, which equals to 0 for this variable am, okay? Or we can restrict our subset as this am equals to 1, so whenever it is 1, that is included in our set, okay? And we can again create this cross tabulation. Or we can change this to another variable like the gear. The number of gears of the car, for example, equals to 3 is our subset that we want to work on. Then we can select this gear equals to 3. Then out of these observations, we want to create the cross tabulation. And we can do that by, again, you can see the frequencies of 4, 6, and 8 cylinder cars given the gear must be equal to 3. Okay, and we can also do different variations of that. We can actually have more than one variable. For example, we can have a matrix tabulation instead of just the row. So in a matrix tabulation, we can enter two variables, such as the variable am and the number of cylinders. So this will be quite useful if you want to see this more specifically, like you have am equals to 0 or 1 in our data set, okay? So we count for am equals to 0, this gives us the number of frequencies for different cylinders. And for am equals to 1, as you see, again, we display the frequencies. So this is a matrix format for tabulating the frequencies, and it is quite useful, I think, to describe your data set. And finally, we can again do a bar plot using the frequency matrix that we created here. We have seen just for the row case, but now if we have the cross tabulation as a matrix, again, you can input this into your bar plot, and we can assign some legend, etc. I mean, you don't have to include everything here, but that is going to basically display us. This time we have chosen the horizontal, by the way, horizontal true. You can make this false, then it will be vertical. So we put the legend manual versus auto transmission, and we count, as you see, the frequencies are given in the x-axis, and we have the number of cylinders, 4, 6, 8, and we can see with different colors for the manual versus auto transmission. With these different colors, we can easily see the frequency. Okay, we have like 12 cars with auto transmission, and they have 8 cylinders, for example. Okay, so this type of bar plot is really useful to summarize your data set with respect to your different variables of interest. Okay, so thank you for watching. That's all for this video. We will continue in the next video.